Hello everybody. Today I bring forward an interesting question. So here's the paper reference. So first, have a go at this question yourself. I'll just read it for you. The diagram shows the curve, a quadratic curve this, and the line L, which is the normal to this curve at the point where x is equals to 5. Find the area of the shaded region. This is a landmarker, so make sure to write down all your workings. So let's begin. So firstly, what you want to do is you write down y is equals to x square minus 9x plus 18. Then what you do is that you'd so you're basically going to take the derivative of this. So dy by dx is going to be equals to 2x minus 9. Once you've taken the derivative, now you know that it's x equals to 5, so you can then plug in the value x is equals to 5, which you should obviously know is equals to, it's a 11 marker, so that's why you have to write down every step. And this is 1, so m of the tangent is 1, so m of the normal, gradient of the normal should be minus 1, because mt into mn are perpendicular bisector equations, so m1 into m2 is always equals to minus 1 if they're both perpendicular. So minus 1 over 1 is So now you can write this in the form y is equals to mx plus c. So m is minus 1, so minus x plus c. Now you'll have to work out what y is at x equals to 5. That would be 5 whole square minus 9 times 5 plus 18, which is 25 minus 45 plus 18. So y is equals to minus 3. So minus 3 is equals to minus 5 plus c. So c is equals to 2. Therefore y is equals to 2 minus x. Now we need to find the area of the shaded region. So if I just remove all my annotations in this graph, so they want this shaded region, this black area, and so I've highlighted this whole portion as green, and then the area under the line L, so that portion as yellow, and then the overlapping stuff we do not want. So this light greenish weirdest color, so we only want this area, we don't want the rest of it. So the simpler way to find the triangle area would obviously be to use triangles. So half times base times height, or you could, if you wish, you could do integration. Whichever way I find integration easier, so let's do integration. So first we have shaded area. So for the shaded area, before we can write this, do you even know where you have to take the shaded area between two, from and to? So you'll have to set x square minus 9x plus 18 equals to 0, or you could just solve x square minus 9x plus 18 is equals to 2 minus x, and then solve that quadratic, which instead of giving you the x value of this one, it would give you for this, so x equals 5. So you solve this to 0, so x square, so if you factorize, so 18 has factors 1 and 18. Do they in any way give 9? No. Or 2 and 9? No. What are 3 and 6? Well, 3 plus 6 does equal 9. So 3 plus 6, so 3 will work. 3 and 6 will work. So x square minus 3x minus 6x plus 18 equals 0. So x factor out x minus 3, and then minus 6 factor out x minus 6. But be careful, because you're factoring out a minus 6, so the minus 6 are here, and then divided this by minus 6, so the positive term becomes a negative. Then you know that x minus 3 is common, so this is like it's saying that okay, I have a many terms of x and I have 6 many terms of x, so ax minus, so this would be a minus 6 into x, so basically x minus 6 into x minus 3 equals 0. So each of one of these must equal 0, so either for x equals 3 or for x equals 6. So we should ignore this x equals 6 because x equals 6 is actually this one. We want the integral between x3 over here and x5 over here. Okay, so now we can write down the shaded area. So the shaded area will be the integral 5, 3 of and by the way, at this point so 5 squared minus 9 times 5 equals 25 minus 45 is so basically this y that we have, y is in reality, it's like it's a massive portion. This is minus 2, so this is 3 and this is 3 x by the so continuing, so basically this is x squared minus 9x plus 18 of the dx minus integral 5 of 3 minus x dx. So basically the area of this can be calculated by doing half times 2, because 3 to 5 is 2, and then this one you can't really have negative length, so you'll have to consider it positive. So this is 2, this is 2, and then half times that, so one of the 2's eventually cancel out, so you just are left with 2. So this, I know the area is going to be 2. So and if just in case if any of these areas comes out to be negative, so we'll put modulus signs in case. So first we can do x cube over 3 minus 9 x squared over 2 plus 18 5 3 after integrating. There are no plus c is required in definite integrals, but for indefinite, never forget them. Then we'll have this, so 3x minus x squared by 2. I think I forgot writing the limits. So writing the limits is 5 and 3. So now 5 cube is like 125. So 125 over 3 minus, then 5 squared is 25. 25 times 10 is 250. 250 minus, take out 25 is 225 minus 225 over 2 plus 18 into 5 is 90 minus 3 cubes, so that will be 9, and then over here, so 3 squared is 9, 9 times 9 is 81, so minus 81 over 2. It will be plus because you have to do the upper limit minus the lower limit, not plus. So the plus over here will be minus, the minus over here will be plus, and the plus over here will be a minus. So it works like that. Minus 54 modulus close. And by the way, this question can't really use a calculator in it, so you have to be careful. So 3 times x is 15 minus, so 5 squared is 25, 25 over 2, and then minus 3 times 3 is 9, and then plus 3 squared is like 9 over 2. So here you can see this is basically saying what is 6 minus 16 over 2, so you get and then for this one, so after simplifying this, you get minus 10 over 3 for this portion, so modulus of that, and then minus the modulus of, so that is minus 2, so What is 10 by 3 minus 2? That is, well, that's 4 over 3. And that is our answer. Thank you for watching.